Okay, well, I'm going to make a short video on converting a Bobier power center, solar power center to a different charge controller. Currently, this Bobier load center, power center, came with an inverter. It was a complete setup. It's actually been in use for the better part of 20 years and has worked fairly well. The inverter didn't hang in there. It was a Vanner. It has been replaced, and we're going to be replacing the charge controller, which is currently run off of the Omnimeter with a contactor in the cabinet. I'll get into that in greater detail. So some thumbs up to Joe Bobier and creating this thing that did run as long as it did, and it's fairly simple in its structure. So let's take a look at what actually goes on with this thing. How do I get rid of that bar there? I'm not sure, but let me move this up a bit. If you look at the bottom of the screen, this is where the battery connections come in. The negative to the battery has white tape on it, and the positive is the black cable that comes from the battery. We'll follow the negative. It goes to this terminal block that has a couple of connections on it, and one of those connections goes up to this bus bar that has a shunt for both the negative of the PV current coming in from the array and a shunt here that is the negative for the DC loads. And I don't see any DC loads connected, so we could just kind of make that a moot point in this particular operation, but I'll discuss it to some extent. The positive of the system, of the battery anyways, on these major connections within the system. Oh, let me back up one more time over here. I went up to this bus bar. There is one other connection, an important one here on the negative block, which comes over and connects to the top of this shunt. And this shunt, we could call it the master shunt, has the inverter coming off, the negative to the inverter coming off the bottom of it. On the battery side of that shunt, well, essentially what the shunt does is it provides a millivolt voltage point for the meter to reference in order to determine how many amps are flowing in and out of the system. Bidirectional with ones like this where the inverter could be charging or discharging. So that's the negative leg. The positive, the battery positive, comes in down here, and you can see there's this copper bus bar plate that connects the positive of the battery effectively to the lower part of this safety pole fuse block. It's a 2-pole fuse block. And the left side of that, the battery connects to the PV contactor. A contactor is just a relay that opens and closes based on whether or not the battery is charged or what the state of charge is. I'm going to switch to a different position here. And in this shot we can see the contactor right here, which is this power relay essentially. And by the way, this contactor is a mercury contactor. I think you want to remove that and dispose of it at one of the operation clean sweeps or something of that nature. You certainly wouldn't want to burn your cabin down or something and then add insult to injury by having this mercury wash into the lake that the beautiful lake that your cabin overlooks. So that's the positive then to the PV input breakers. And I'm going to switch back to the other image, and then so these would be the 4 breakers here, or 3 breakers rather, that would be the input breakers for the array. I'm going to go into a little greater detail up here in just a second. If you want to follow this over here, the other half of that 2-pole pull, of course, is the inverter connection. Here's the positive out of that safety pull to the inverter cable, and the one that feeds the DC loads. So those are the primary connection points for this. If we want to take a look up here at the PV, let's zoom in just a little bit. Here's where the two conductors come off the roof from the two sub panels of your array. And these two breakers, of course, controlling those. It's interesting to note what Joe did here was he just used a square D load center, the guts of one. It's turned upside down. Here's your primary lugs. And the way these are set up is these, a breaker here and a breaker on the other side of that would be on one lug, and then the next two breakers would be on this lug. So he alternates them. These are your DC loads, and they're all on this lug. These are your PV inputs, and they're all on this lug. Now, of course, if you, for instance, ran out of PV, if you put on, 4 series strings of PV input, you could even use this one for a PV input or this one for a PV input. That would be on the same bus. But, of course, then the cabinet would be improperly labeled, and he's got this split in this fashion. And most people don't need more than 3 input breakers in a little system like yours. So in any case, that's where the PV comes down, and then of course it comes through those breakers and into this cable, which goes to the other side of that mercury contactor you're removing. So that's going to be out of the mix. Your negatives come in here. Now, connecting the Kid, you're switching to a Midnite Solar Kid, which is a 30 amp charge controller, MPPT, maximum power point tracking, a nice solid state, rock solid controller. It should serve you well. What we're going to be doing is the PV negative off the roof will come in right here, and we're going to be removing this cable. This cable that connects the PV negative to the shunt will be removed, and the PV negative will come into this connection point in replacing that cable. The charge controller, the Kid, has an internal shunt for its PV circuit, and that's the way that's going to get wired in terms of the negative. The positive to the PV positive to the Kid will make its connection here. So you're going to be using number 10 stranded, THH, THWN, and that's going to be connected over, from the controller, the PV positive to this connection point once you remove that. So the battery positive, by the way, might as well just do the Kid right now. The battery positive, I'm trying to remember, will go right down here. This is the other side of that contactor circuit, and this will become the Kid's battery positive. Now, this T-class fuse in this safety pull is probably 60 amp or 100 amp or something like that. I guess I wouldn't get too excited about that. It still does give you the safety pull option. In other words, you can use this safety pull as a disconnect, which is required. It's not the best way to do it, but it'll suffice. And the Kid does have its own fusing on board, so the code would say that those fuses do not meet the requirement for a disconnect. I would think your safety pull would, while still having the fuse in the Kid adequate for protection of that device. So you can stick with your number 10, which is what the Kid is wired with, as long as you're going to mount the Kid essentially on the cabinet. Let's take a look at that once. One possible location for mounting the Kid would be right on the cabinet door. I think this hinging is fully adequate that came with the Bobier unit, and you could consider bringing those wires right through the back of the connection point on the bottom of the Kid, and could make the installation pretty smooth. Your wires would be very short, and of course you would have to set this up with some wire ties and whatnot to have it so that the bundled cable of wire coming, there's like 4 conductors and the sensor wire to the shunt, those could be bundled in a way that when the cabinet closes, they operate or fold up much like the Omnimeter cabling does. So one possibility. So in other words, where I was going with that is you wouldn't want to take that number 10 wire a long distance over into another part of the house where it might be more convenient to meter. You'd want to be bumping it up to something heavier than a number 10 with an extended wire run. So I think we'll just kind of skip that concept and keep the charge controller nearby here, if not on the cabinet, on the wall next to it with some conduit between the two. And you could use liquid tight flexible conduit or something like that. Okay, where was I? That was our PV circuit. The battery positive going to this connection point down here. The battery negative going to one of these connections. I don't think I covered that. That's the final connection. Actually, if you were going to maybe leave these shunts in play, and it's possible you could leave the Bobier Omnimeter powered up and still get some additional metering out of it, perhaps. We'd have to think about that a little more. But then here's where your battery negative would be to the PV point in the, I'm talking about the battery negative connection in the Midnite Solar charge controller would be to this lug right here. So there's your battery positive, battery negative, PV negative, and let's see. The next thing that we would have to be doing is the connection for the shunt here. This is going to become the master shunt. And we would be taking this cable that goes currently, I think it goes up to here, and we would be moving that cable over to the bottom of this shunt in this open port right here. Now it looks to me like that cable's not going to be long enough, so you'd want to probably get something on the order of a number 2 if you want to stick with what's going on in this fuse disconnect here, or a number 4. Technically a number 10 would suffice, number 10 cable, wire, but I'd say let's keep it consistent with the wiring in here if possible, and we'd be replacing that with a number 2, or like I said, a minimum maybe number 4. This then becomes your primary shunt. These two are not in play with the whiz-bang monitoring in the Kid, and if you will consider removing these two brass lugs. Of course, everything is dead in this cabinet at this point. Battery's been disconnected. I probably should have mentioned that up front, but it might have been a good idea. If you take these two off, these terminal blocks will come off of here, and they're just attached to these cablings that are coming in here. And you'll be able to see this is just a shunt, and on the side of it is 2 connection points where this being a 50 millivolt 500 amp shunt, full scale, if you were putting 500 amps through there, you'd measure 50 millivolts voltage drop across that shunt. It's very, very, very tiny amount of resistance that the meter uses to determine how many amps are moving through there. So on the side of that, you'll see where the 2 wire connections come from the Bobier's meter, the Omnimeter, and connect to that shunt. Looks like it's probably on this side. And the Whiz-Bang Junior comes with some spacers and things to bolt that Whiz-Bang monitoring board onto the side of that shunt. And I think you'll be able to figure out how that goes on there. You could consider then slipping the existing Omnimeter connections to that same connection point to continue monitoring that shunt on the Omnimeter. The one thing that I would say is that it's going to change kind of the math that the Omnimeter does. We used to have 3 different shunts in here, and you can actually reprogram all that in the Omnimeter to tell it what's going on with which shunt. But it was going to do the math on what was coming in and out of the battery, and as to whether or not it's a load or a power supply circuit. So that would be interesting, though, to just leave it all connected and see what that meter does for you. Let's see. Then there's a single conductor that comes off of that Whiz-Bang Junior that connects to the correct port on the Kid charge controller, where you'll also plug in your temperature compensation probe, which goes down into the battery box. Let's see, what else am I forgetting here? We've got to remove. One thing you could consider doing, by the way, is the Kid does have DC load output that you can control with the controller, so you can program the controller to power a load off the battery that will disconnect at a user programmable set point. You can use it for night lighting where it turns on at night, or you can use it for whatever. And if you decided you wanted some night light to come on, or if you had a bunch of DC loads, and again, it doesn't look like any of these breakers are in use, so you must not have any DC lighting or anything. But if you did, you could also program the controller to shut that thing off if the voltage falls to a dangerously low set point, user-defined set point on battery discharge. Excuse me, I got some hay fever stuff going on. My throat's pretty raspy. How do I get rid of this thing? Minimize. Okay. So I think I covered it all. Your battery connections. Let's see. You could also consider. Oh, if you were going to do the loads. If you were going to power these loads, these circuits off the Kid's load output, you would remove this cable here, which is currently powering these loads directly off the battery through the main breaker there. I'm sorry, fuse, that large T-class fuse, which is pretty hefty sized fuse for those square D breakers, but they should be able to handle it. Anyway, I think that's pretty much all of it. We're taking that out of there. We're getting rid of these guys. Here's our battery. There's our PV output. And PV negative is going to be right up in there with the battery negative taking place like here. I'm sorry, here. If you're going to keep this stuff in play. And this cable removed, and yeah, this we're changing up where we're taking the negative off of there and we're putting it down here, so it's all flowing through this shunt and should be good to go. We'll talk to you later, Kirby. Okay. Where's my box to shut this thing off?